You know, there are 10 types of people in this world. Those that understand binary and those that don't. Oh geez, here's a scooter. I never know what to do in these situations. I'm just gonna wait and see what they do. Is he gonna turn? Go on, dude. Turn. What's he doing? What are you doing? Go ahead, turn. Is he gonna go? Turn. Ah! Oh my gosh! Oh my gosh, is he okay?
All jokes aside, though, nobody was hurt. Don't worry. According to the U.S. Consumer Product Safety Commission, injuries involving e-scooters. I'll share links to all of these sources in the description. A very clear part of the problem is lack of visibility. I think we can solve this problem. So we learn in ENME 351 how to actuate an LED using Arduino. But how can we do this with a sensor that doesn't require the use of the hands? If you guessed accelerometer, you're right. Our solution knocks out two birds with one stone. Increased visibility and protection to the rider once this circuit is implemented into a helmet. So for starters, we're using two libraries here. You can view the description for links to both of these libraries. We're going to define everything here, create some objects, create some flags that will be utilized in the logic portion of our code. The heart of this project, though, is communication and operation between Arduino and processing code. So first, we're going to initialize serial communication. Then check for the MPU 6050 sensor and initialize it. And then also initialize the LEDs. For the processing code, setting up communication, we're going to create a serial object using my port and make sure to use the same port and baud rate that we are using for the Arduino. Now we set up communication for both Arduino and processing. We want to use Arduino for data acquisition and transmission. First, we're going to read the accelerometer data for the acceleration in the X, Y, and Z that we are receiving from the MPU sensor. After reading and printing the acceleration data, we're going to use some logic to determine what to do with it. Based on the tilt in the X direction, it sets a corresponding flag. Greater than 5, blink right, or less than -5, blink left. It then prints a message to the serial port indicating the tilt direction, right or left. Lastly, it calls the blink LEDs function. If it's tilted to the left, it actuates LED pin 5, and if it's tilted to the right, it actuates LED pin 6. On the processing side of things, we have data reception and processing. First, it reads the incoming data stream from the serial port, parses the received string into an array of 3 values, X, Y, and Z acceleration, checks if 3 values are received and converts them from strings to floats, mimics the tilt direction logic of the Arduino, checks if X-axis acceleration exceeds thresholds and the corresponding blink flag is not set. If tilt is detected and the blink duration has passed since the last blink, it sets the appropriate blink flag. Blink right or blink left. Based on the blink flags, it draws the black circles and centers circles representing the PCB and LEDs. It iterates through 8 positions to draw the individual LED circles on the left or right side depending on the active blink flag. It sets the LED color based on whether it's blinking orange or not blinking white. Okay, so here is the circuit and you can see the processing code on your screen. So we're displaying our acceleration in the X direction, the Y direction, and the Z direction. The X direction has a slight tilt in the negative right here because just the way that it's set on there. But if I go ahead and tilt it to the left, it will blink the left LED at the same time on the screen in real time 10 times. And then when I go ahead and tilt it to the right, it will do the same thing for the right LED. So you can see X equals +5, it blinks the right LED. X equals -5, it blinks the left LED.